Hi everyone, I'm Bastian. I'm working on the lighting specification, especially some of those things that we're going to be talking about. And yeah, today I want to talk about a lot of things that you have heard. You have heard these terms mentioned for a while, for years now. So I want to dive into them because they are finally getting real. So you'll get the opportunity to finally learn what those things are. So mostly dual funding, splicing, and liquidity ads, and how all those things work together really well to make your life easier as an operator and also as an user. So yeah, those are terms that don't mean anything. When you see that, what does splicing mean? So we'll go over that talk, that by the end of the talk, it will make sense, it will be easy, and you will understand why some of these things take a while. So let's start with the first one, because this is the one that is closest to completion, and this is dual funding. Before dual funding, when you open a channel on the Lightning Network, when Alice wants to open a channel to Bob, only Alice is allowed to put funds into that channel. And that creates issues, because if Alice opens the channel to Bob, that means that Bob cannot send money on that channel yet. So usually, Bob just ends up opening another channel to Alice. So there's one channel from Alice to Bob and one from Bob to Alice. It would be a lot more efficient if they could just both collaborate and make sure that when they create the channel, they both have funds into it, if they both want to. So dual funding is basically just that. We can both contribute to a channel when we are opening one. It looks simple, right? How come it took years to do that? It's just building a transaction with two people and making sure that two people are able to add inputs to that transaction. So it's actually not that simple. So actually, we could do it in simpler ways than what we did, but we chose to do it in a less simple way that lets us compose that with other things. So one of the main goals of dual funding was to create a generic protocol that lets two or more than two parties build a transaction collaboratively. That requires a lot of interaction, and that is basically what makes it hard. But what's interesting is that once we have this protocol, we can actually then reuse it for a lot of other things that we're going to be doing on Lightning, and that's something that we'll see with splicing. Some of the reasons why it makes it hard is that we first need to decide who pays the fees for that transaction. Because if you are both collaborating to a transaction, would it make sense if only Alice paid the fees for that transaction? If she did, Bob would just take this opportunity to do whatever other payment he's trying to make, pay join, coin join, do everything here, and then Alice pay the exchange fees for that. That wouldn't make any sense. So the way it works is that each person in that protocol will pay for the inputs and outputs that they are adding to the transaction. But there are common fields to the transaction on top of the inputs and the outputs. There's the inversion field, there's the log time field. So someone has to pay for that. And here, this is the guy who initiates the transaction that pays for it. But as the transaction grows bigger, this ends up being a very small percentage of the actual transaction. But there are still issues. Yeah.
This scheme here, is it substantially different than what was presented in the original Lightning white paper, or was that just too hard in the first place and nobody got around to it yet?
What scheme in the Lightning white paper?
Well, the original white paper has dual funding in like the early part of the chapters of it. I mean, nobody implemented that until now. And I'm just wondering if that original scheme that was presented in the Lightning white paper was flawed, or it was just kind of everybody was too busy?
I don't remember of that scheme. So I don't think it's the same scheme, definitely not. But I don't even remember that there was a dual funding scheme in the Lightning paper. So I'll have to read that. I can't answer that right now.
Okay.
But on the fees, there are a few tricks. For example, you can still play with the fees because okay, let's just go through the example and the messages that we load. So on the left, you see this is a protocol execution. The messages should be somewhat self-explanatory. Alice wants to first add an input to the transaction, so she's sending this to Bob and she says, I want to add this input, and she's going to give the transaction of that created the UTXO so that Bob can verify that this UTXO is legit. Bob can do the same thing. They can exchange messages like that for inputs. Then they can add outputs to the transaction. Then they can also remove inputs or outputs. And this is mostly used to be able to prevent deadlocks when we do batching across multiple sessions. And when they are done and have added all the inputs and outputs that they wanted, they just say, TX complete. I'm done. I have added everything I wanted. We can now finalize that. And when both sides agree that they are ready to finalize, then we exchange signatures from that transaction, and then we have the opportunity to restart and initialize RBF if a transaction is not confirming quickly enough and we want to bump the fees. So one of the goals with the way this is built is that it allows batching, which means that if you are trying to open a channel to Bob and also trying to open a channel to Carol, you can actually do those two in parallel and end up with only one transaction. You would send inputs, you would just relay everything from your channel with Bob to the protocol that you are running with Carol and the other way around. So in the end, on both protocol execution, you end up with the same transaction and you just have to relay signatures from one channel to the other. And with only one transaction, you've been able to open 2 channels, or 3 channels, or 4 channels. Or you've also been able to do a paint join, or a coin join, or anything that you wanted to do. So that's a really interesting and generic protocol, and that's what took a while because there were issues to make sure that we could do that batching without potentially having a deadline. Also, another cool thing is handling disconnections, because before that, when we were opening a channel, it was somewhat more atomic, and when you gave signatures, you only needed half a round trip to complete it and to break up the transaction. But here you are exchanging a lot more messages, which means that if one of the side disconnects after going through all the pain of creating that transaction and they disconnect in the middle of exchanging the signatures, you want to be able on reconnection to make sure that you just resume that operation and complete the channel opening instead of having to go through re-adding the inputs, re-adding the outputs, especially since it usually requires locking those inputs in your wallet. So that was also something that was not trivial and is now fixed. Another thing we wanted to support is obviously RBF, because one of the issues with channel opening right now is that if you open a channel and it never confirms, the guy on the other side of that channel will eventually just forget it, because they cannot keep using resources for a channel that never confirms, in which they don't have any funds. So at some point they will forget about it, which means that you are stuck with a transaction that you can only spend by yourself by using a commitment, which is expensive, which is really an issue. So you want to be able to RBF those transactions, which is something we are doing. So this has taken a while to be somewhat complete. It has been started by Rusty and Lisa mostly, and I've been working on reviewing that and implementing it there. We are very close to having a cross-compat test. The only thing that we're missing is the disconnection, reconnection part that is not completely done in CLN right now. But it should be a matter of weeks, and then we're going to be able to actually ship that thing. And it's also already shipped in Equinor, in Phoenix. So if you're using Phoenix, it's already using the open right now. Yeah.
So when outside about contribute to both of them have to contribute same number of networks, same amount of networks,
No, they can do whatever they want.
Okay.
So they say how much they want to contribute to the channel at the beginning of the protocol. Like Alice says, I'm going to be putting half a Bitcoin into that channel. Bob says I'm going to be putting 0.1 Bitcoin into that channel. But they could add amounts that must be at least that, but they could add a lot more and take this opportunity to do other payments and other outputs. So.
And you said the opener pays the fee? Is that what you said?
You
said the person opening the channel pays the fee?
No, the person opening the channel pays only the fees for the common parts of the transaction, conversion, the lock time, and the inputs and outputs that they are adding. But the other guy pays the fee for the inputs and outputs that they are adding. But basically, each party pays the fees for what belongs to him or her in the transaction.
So depending on how many bytes they put in.
Yeah.
You had mentioned that this protocol allows for batching across multiple pool funding operations. Does the initiator have to be the same in all cases, or is it possible for a client, the responder, for someone to initiate dual fund that also dual fund in other channels at the same time?
You have to be the initiator, because otherwise you can try doing it opportunistically, but the issue is that if both Alice and Bob are trying to batch with unrelated things, then there can be a deadlock. So if you try it when you're not the initiator, maybe that will work if the other guy is not batching or is batching in a way that is compatible, but in most cases it won't. So when you want to do batching, you should try to be the initiator. Alright, so next step is splicing. One of the issues with Lightning channels right now is that once you have created them, you cannot change their size, which is really an issue because if you realize that this is a good peer with whom you're really a lot of payments, you want to potentially add more liquidity. The only solution that you have right now is to open another channel. And if you have two channels with the same peer, that means that when those channels close, you have to manage two closing transactions, pay the fees basically for two closing transactions before you can open another channel. It would be much easier if you could just increase or decrease the size of that channel so that it doesn't add any more cost in the future to actually close that channel. So splicing is just that, changing the size of a channel. What could go wrong? That should be really easy as well, right? So the interactive TX protocol that we use for dual funding was explicitly designed to make sure that we could also reuse it for splicing, which makes splicing somewhat easy on that front, but with a few additional details. Because in that case, there's one additional requirement that the splicing must add as an input the previous output of the channel, because you are actually spending the channel funding output and just creating another one, and potentially adding and removing funds at the same time. So the main issues with splicing are that you are maintaining two history of commitment, parallel history of commitment transactions at the same time. So in this graph, for example, you have a funding transaction that is already confirmed, where this is blue, where Alice has 0.6 Bitcoin and Bob has 0.4 Bitcoin. She has a commitment transaction that spends this funding transaction, and then they want to do a splice. And in that splice is going to spend the funding transaction. So this splice is double spending the commitment transaction that is on its left. And Alice is also adding 0.5 more Bitcoin. Bob is adding 0.2 more Bitcoin. And in the output, they are actually only adding 0.3 Bitcoin to the funding output and doing other things on the side, which are the other two options that belong either to Alice and to Bob. And once they've created this splice transaction, they also have now a commitment transaction that spends this splice transaction, which is supposed to be the new state of the channel once this confirms. But before this confirms, you have to maintain both of these commitment transactions could end up on chain. So you have to maintain, while the splice is unconfirmed, you can still make payments. We don't want to block that channel. We want to make sure that as soon as you have created that transaction, you can still resume channel operation, relay payments, earn fees for that. So those commitment transactions will be revoked, replaced by new commitment transactions, but on two different histories basically. And you have to keep track of all those histories and of potentially someone trying to cheat by broadcasting the commitment transactions from our old history. And it's interestingly, since you can do RBF for the splice transaction, you can potentially have an unbounded number of parallel histories that are happening and for which you need to keep track of. So this was one of the major implementation issue, and it plays especially not nicely with ZeroConf, because in ZeroConf you cannot do RBF, you only have to do CPFP and create more chains of potential histories for that channel. So this is hard. And one of the other hard issues with splicing that is not solved yet is pinning. Whenever you create basically a layer 2 protocol that relies on chains of transactions, just don't tell Antoine Réard because we find a way to pin it. And that can expose the channel to attacks where people could potentially steal funds. I'm not going to go into details about that because that is a whole talk, but there are a lot of resources around pinning. I've written articles on GitHub about pinning Lightning transactions, and this is something that will be solved once we have package relay and B3 transactions that core developers are working hard on. Another thing that is hard is the gossip, because whenever we currently maintain the graph of all the channels in the system, and every Lightning node has a copy of that graph. And the way they know when to add things to that graph is that we tell people, look, I just opened a new channel, here is the UTXO on chain, please add it to your graph. But we don't do anything to tell people that we close the channel. But you still want to be able to know when a channel is closed, because you don't want to send payments through a channel that is closed, because it's just going to fail. You're going to waste you're going to waste latency trying to send the payment to someone who will just pay it back. And if you do that, and a lot of the channels you are trying to use are closed, you're going to have payment reliability issues. So you want to be able to detect that channels are closed, and the way you do that is that you just watch the blockchain and you wait for the transaction to be spent. But here, when you are splicing, you are spending the funding transaction, but this is actually not closing the channel. So you need a way to tell people that this is a splice, this is not closing the channel, this is just increasing its size, and people should expect another announcement for the new size of the channel. But there are no perfect ways of doing that, and we're still working on how to do that correctly. So same as dual funding, this one has been mostly done by the CLN team and the Eclair team. So Rusty, Dusty on the CLN side, and Pierre-Marie and I on the Eclair side. It's been fully implemented in CLN and Eclair. We are not yet completely ready for post-combat test because there are only a few details that we do differently on the exact things we send in those commitments. But the protocol is basically the same, so we should not have any issues doing post-combat test once this is ready. And if you're using Phoenix, that is already shipped, and that's something that you can use right now. Yeah.
When the splice transaction is still waiting to be confirmed, what happens if someone tries to cheat before it's confirmed?
Cheat how?
Well, so you said that the channel can still be used for payments, right?
Mm-hmm.
So, like, what if the channel is used and some payments take place, and then one of the parties tries to broadcast an old transaction?
You just have to keep track of that. That's one of the things that if you don't take great care in rewriting your implementation for that, you may have forgotten the history of revoke commitment of the previous funding transaction, and then there's an issue and people can still fund. So you just have to correctly implement it basically, and keep track of those, keep watching those commitment transactions that have been revoked on the old history, and you can only forget them once the splice transaction has been confirmed, because then the other cannot double spend it anymore. So you just have to keep track of it. It's additional code, but it's been implemented and it should be working correctly. Yeah.
With the new gossip of the channel size change, does the channel ID change as well, or?
So we're not changing the channel ID, but we are changing the short channel ID, which is that's the short channel ID is just referencing the UTXO chain. It's the block height, TX number, and output number. So this thing changes to reference the real new UTXO because the other one has been spent, so we cannot reference it anymore. But the channel ID, which is the 32 bytes, just random ID, this one is going to stay the same. So this is the stable identifier that you should keep using for our functions. All right, and last one is liquidity ads. So the goal here is that we've seen that with dual funding, we can potentially both contribute to a channel. But if some random node connects to me, why would I put liquidity in that channel? I don't know that random node. I don't know if they're going to generate revenue for me. I have no reason to put liquidity in there, but maybe they want me to put liquidity. So what if they could just pay me for that? I just need to advertise my quotes. Basically, I just need to tell people, if you want me to have liquidity on the channels you open to me, just pay me that amount. So same, that looks really simple, but actually there are a lot of details that make it not as simple. So at least the broadcast part is really simple. There's a message that we send on the gossip that is called node announcement when you announce details about your node, like your IP address, your node ID, and the features that you support. We just add to that announcement a new quote for liquidity saying, if you want to buy liquidity for me, this is going to cost you that base amount, and this is going to cost you that proportional amount depending on how much you want me to add to that channel. And then also something about the routing fees that I will apply. It's really interesting because it creates a decentralized and open market for liquidity instead of the existing centralized markets, and this will create good competitivity here. This will solve a lot of issues for users because people will be able to connect to any part of the network and be able to get inbound liquidity from those channels, and since everything is open, hopefully at some point it should reach a price point that is just right. But it creates issues on the implementation side because potentially people can breach your liquidity because if someone opens a channel to you and says, I'm ready to pay you to put some liquidity and you lock a UTXO in your wallet, but then they just don't complete the channel open, you are actually locking liquidity. And this guy is just making you lock liquidity that you could use elsewhere. So you need ways to defend against that, and that was one of the hard issues to protect against. Also, you want to prevent the guy you are buying liquidity from just closing the channel instantly, because if I open a channel to you, I pay you to have inbound liquidity to me, but then you directly close the channel, I pay you for nothing basically. So that's something we need to prevent, and the way we prevent that is that we add time locks to the transactions, to the Lightning transaction, commitment transaction, and HTLC transactions, to make sure that the guy who has been paid to put liquidity in cannot close before that time basically. You are paying for a lease of, I think it's 1 month by default, and for 1 month, the other guy, if they close the channel, they cannot get their funds back, so that they are incentivized to keep the channel open. And also, you want to know how much routing fees they will put towards you, because if I buy liquidity from you, but then you tell the rest of the network that to get to me, it's going to cost a very large amount of fees, nobody is going to use that liquidity. So that's why in the lease that in the quote for inbound liquidity that we put, we also put the maximum amount that we will put in routing fees in that channel. But here you cannot prevent those from changing them. But the only thing you can do is that they have signed this quote, and if they sign a channel a day later that puts a higher routing fees than what they advertise you, you have a proof that they cheated, and you could potentially put that somewhere publicly so that other people do not use them for inbound liquidity. But we cannot do better than that. It needs a bit of spec update because right now it uses absolute block times, whereas it could just use relative block times and it will make it pretty simpler. It has been implemented in CLN and it's a work in progress in Eclair, but we need to do some updates to the specification. So this one is going to take a bit longer to get, mostly because of a liquidity briefing issue. But then, apart from that, there are no big blockers. It's just about taking the time to do it. So cool. Yeah.
I had a question on are the channel fees negotiated in the ad itself or just the
Which channel fees? What do you mean by channel fees?
So if you buy incoming from me and I just set the channel fees very high, it's not much use to you, right?
You mean the on-chain fees for the funding transaction?
No, the lightning fees.
The routing fees. Yeah.
Yeah.
Okay.
So
Yeah.
does the buyer of a channel have a way to ensure?
Yeah, that's what I'm putting here. In your inbound liquidity quote, you put the fees for the actual liquidity opening, but you also put the routing fees that you're going to use, and you can put many quotes in your node announcement. For example, it's that price if you want to have those fees for rounding, that price if you want to have a lower fees for rounding, and this way it is signed by the guy you are paying, so that if they change routing fees later to cheat you, you can prove to the rest of the world that they cheated.
Yeah, you said are the ads a gossip message on the network?
What do you mean by ads?
When you advertise.
Oh, okay, but liquidity ads, they are in your node announcement. The node announcement is the main message to announce your node and the features you support. Right now, it's not updated a lot because it's only updated when you change your features. But once we add liquidity ads, that's an opportunity to update it more frequently.
Is that going to be a scalability problem if everybody's sending these updates all the time or it's a gossip network?
It doesn't need all the time. We're probably going to drop them, so that means people will not get liquidity, and it's going to be an issue for them because people won't be able to find their accurate liquidity, so they don't have good incentive on spamming the network. So we'll have to rate limit. They'll have to avoid spamming, but also they don't necessarily need to spam it that much because you could also send those quotes directly when you connect to the node. When you connect to them, they could give you up-to-date quote, and if that doesn't match what you wanted, then you just disconnect and go elsewhere to buy liquidity. And this way, you're not spamming the network. It's only when someone connects to you that you give them the most up-to-date quotes. But I don't expect those values to be changing like every minute. You don't have a good reason to change those things extremely frequently. Yeah.
So when you say you prevent instant closes, is that both block and force closes?
what we prevent is that if Alice is buying liquidity from Bob, if Bob force closes, Bob cannot get his funds back before the liquidity lease expires, which is 1 month. So Bob really has an incentive to not force close because his liquidity is going to be locked for 1 month anyway because Alice paid for that.
But if Alice goes offline, Alice goes for whatever reason, let's say Alice is no size, and then Bob's liquidity is stuck in that channel, that also increases the risk for Bob.
No, because Alice paid for the liquidity. So Bob cannot get it back after the end of the lease, but Alice paid for that liquidity anyway. It's not going to generate as much revenue for Bob because he also expects to make routing fees on it, but still Alice paid something for that.
Okay.
Yeah.
If these messages are in the node announcement, that also means that the liquidity ads can't actually be differentially priced for people who are connected, right? If I'm looking at a node operator, and a node, I might have 2 different nodes want to connect to me into one, and if I'm analyzing my own risk reward profile, I might have different incentives to connect to each of them, and they want to offer different prices. This doesn't allow for that. Is there a way for us to be able to do both, or we have a baseline one, but also offering differential pricing at the time of connection?
Yeah, you would do it at the time of connection, exactly. When someone connects to you and they're sending it, you can then send them updated quotes, especially if they are reduced quotes compared to the ones you advertise to the rest of the network. We do that here. Putting it in the gossip would be an issue because if you wanted to do that for every other node, then it's a quadratic issue and you just cannot put that on the network. But you would put your normal quote in your node announcement, and if people that you really like connect to you, then you give them discounted quotes when they connect. Okay, so now why do we care? Because now we know that we roughly know how this works. Why is that useful for the network? Why do I think this is worth spending my time on? So first of all, batching. This is really useful because it saves on-chain fees, and saving on-chain fees, we're going to dive into it a bit more later, but this is really going to be interesting and useful for in the long run. It also gives you better privacy, mostly because you can batch those things with coinjoins, with pageants, and you can shape your transactions any way you want so that they don't really look like Lightning transaction. So here, for example, on this diagram, I'm just showing that you can potentially do opening transaction that opens 3 channels with 3 different people, and that's something that I really expect people to start using right now. So the numbers I put in the table for the fee saving, you should really take them with a grain of salt because it really depends on how exactly you create the transaction, if you have change outputs or not. But this gives a rough idea that dual funding and batching those transactions is always going to be more efficient than non-batching at all. So whenever you have the opportunity, you should do batching, especially here where the interactivity, if you are coordinating that, the interactivity is not so much of an issue when you are doing it with other routing nodes that are always online. So this should be somewhat easy to complete. And the most important one is liquidity allocation, because splicing allows you to very efficiently reallocate your liquidity. And the main issue with Lightning, the main reason why Lightning is hard, is that you are actually locking liquidity as a routing node. You are locking liquidity with some people. And if there's just no traffic going through that liquidity, this is just capital that is staying idle, and you could have been earning money on that capital, and you're not. So that's really something you want to fix, because if you do that all the time, you're just going to lose money, and you're going to go out of business at some point because other people will be more efficient than you at managing their money and putting their liquidity where it's actually used and where it generates fees for them. So you want to have the best tools you can to be able to move your liquidity around to where it's actually needed. And this is going to be a very competitive environment. People who don't have the right tools or are not able to use them correctly are going to pay more fees than people who do. So they will eventually not be competitive with the people who actually manage their liquidity correctly. Here in this diagram, for example, Alice has 2 unrelated channels with Bob and Carol, and she can create one single splice transaction, the funding transaction that is in the middle, that is actually splicing on both of these channels at the same time to take some money from the channel on the left. She's taking 0.5 Bitcoin from the channel on the left, and she's reallocating it to the channel on the right. Because the channel on the right, for example, has a lot of routing activity, whereas the channel on the left doesn't have any routing activity. Right. Okay. And another interesting thing that we realized is that Lightning nodes are actually the buyers of last resort for on-chain space. When you are a Lightning node, you want to be very efficient with the on-chain fees that you are paying. You don't want to be paying on-chain fees when the on-chain fee rate is really high, but you still have to make a lot of on-chain transactions. And Lightning doesn't completely decouple from the on-chain world, because you will always, even in a world where we have splicing and everyone has a channel, you will constantly need to move your liquidity around to where it's being used, so you will constantly need to make on-chain transactions. And in the long run, the on-chain fees are going to be much higher than they are today, and you don't want this price to bleed into the price that you make the off-chain payment cost. So Lightning nodes will be constantly, and are already constantly monitoring the mempool and taking advantages of times where the mempool, where the fees are actually somewhat low. So our hope, there's no reason to, we cannot be sure, but our hope is that the fees are not going to be staying consistently high, and that they will be fluctuating, and there will always be opportunities for the fees to go down a bit, and that's where all the Lightning node operators will come in and buy that on-chain space, because it's a bit cheaper than it's usual already. So since you have a low time preference when you are a Lightning node operator, because reallocating your liquidity when the on-chain fees are really high, maybe it's worth waiting a bit for the on-chain fees to drop a bit and then reallocate your liquidity. You're going to take advantages of those drops in the price for on-chain space. And this is going to also good for miners, because it means that those drops will not go to one set per byte. People will always be here to buy that on-chain space at a higher price than 1 cent per byte. So this gives the miners revenue. So miners should really like Lightning, because Lightning is not stealing revenue from miners by moving all the transactions off-chain. Lightning will always need to use a lot of on-chain transactions. They will just want to do it when it's the cheapest. All of those things also solve the inbound liquidity problem, because when you're on node on the network, it's really nice, it's an open network, you can join whenever you want. But if you join and open a lot of channels to a lot of people, it's useless. Basically, no one can reach you, because all the liquidity is on your side. So you are here on that network, you are advertising yourself and say, hi, I'm Alice, I'm in the middle of Bob, Carol, Dave, and Eve. Please route payments through me, because I want to earn fees. But then you cannot route any payments, because there's no inbound liquidity to you. And right now, the only solution is that you do that, you open all those channels, and then you have to send payments out before you can get payments in. So you don't want to send payments out, so you have to do those swaps to just get some inbound liquidity and pay another on-chain transaction just to be able to get inbound liquidity, whereas Bob, Carol, Dave, and Eve could have easily provided that for you. So this solves this really hard problem that newcomers on the network, if they have funds, they're going to be able to get up and running instantly by paying liquidity ads from a node they want to connect to. And it also generates yields for people who are running nodes and have capacity and are just waiting for people to pay them for that capacity. Another thing we are thinking about is that solving this inbound liquidity problem. Solving the inbound liquidity problem is mainly an issue for wallet users, because if you want to make a wallet that has good UX, people don't want to think about that. People don't want to know that they cannot receive that much and that an on-chain transaction is necessary. So maybe here, liquidity ads and splicing, you could use a subscription model where the users pay your liquidity ads and you constantly splicing funds to guarantee that they keep having that inbound liquidity, so that they don't have to care about managing it themselves and they always have enough liquidity to be able to receive those payments. That's a potential solution to that problem. To be honest, I don't know if people are ready to pay for that, to understand this, even though people are paying a credit card subscription, but they don't realize that it could be potentially the same thing, and just paying monthly for a wallet that just works could make sense. But I don't know, people don't like paying for things on the internet, so we'll see. I have no idea, but that's a potential way of getting good UX for Lightning wallets, and that needs splicing and liquidity ads. Alright, so it looked pretty simple, but it actually wasn't. But we are getting there. We are building those things, and most of them are close to ready. So you're going to be seeing them on the network, and hopefully the tool will start building the tools to make sure that you can use that and see your on-chain costs go down as you operate your node. So yeah. Any more questions?
You have that timeline we were talking about liquidity at least that prevent you from slicing.
It doesn't prevent you from splicing. It just prevents you from getting your money back if there is a force close. But it doesn't prevent you from splicing, especially if no one is trying to cheat. It's just that if someone is trying to force close, no, it just prevents you. No, it shouldn't create any issue. If the other guy force closes on his transaction, you don't have to put the. Maybe you don't have to put the timer. Maybe you do, but maybe you don't.
Can you walk through how liquidity acts as trustless? So I deal with someone I want to sign one liquidity. They give me a code, and then I initiate an on-chain payment.
No, you don't do any payment.
Okay.
It's just that they're going to give you a quote, and then you're going to start doing dual funding. Then you're going to start doing dual funding, and in the parameters for that dual funding, there's going to be that quote. So both people will know that when they generate the commitment transaction here that spends this funding transaction, we'll make sure that the price has been paid, and that if Alice is buying from Bob, that Bob gets some money from the inputs that Alice has added to the
So what if I don't want to commit any funds? I'm only buying inbound. So
if you're only buying inbound, then you need something else. If you're not putting any fund in the channel and only buying inbound, then you're going to need something else. Then we can do it with something else that we do at least on Phoenix, but it's not completely ready to be specified, mostly because we need package relay to make it very work correctly. Is that in that case, I can open a channel to you, and I can do it. That's something we do reactively when you are receiving an HTLC, and then we open a channel to you and we deduce some amount from the HTLC. But if you're just buying without an HTLC coming, then you're right, we're going to need another mechanism to prepay for that and find a way to make it trustless. But yeah, that hasn't been specified yet. Yeah.
You're talking about how the channel still useful while the splicing transaction is still occurring. Isn't that you have many transactions for both histories being updated?
Yeah, so one interesting thing to realize that if I am doing a splicing that has more liquidity, until that splice is confirmed, the most restrictive funding transaction is the one that applies. I cannot actually use that new liquidity before the splice confirms because that would create an invalid commitment on the order history. So while splice transactions are unconfirmed, you only take the most restrictive of all the potential funding transactions. So you need to wait for it to confirm to actually really start using that new liquidity. But it just means that when you are splicing in, until the splice transaction is confirmed, you can still process payments, but just not more than before, which is okay because if you hadn't spliced, it would be the same. Yeah.
In the scenario that Paul mentioned about the, let's see, combining splicing and liquidity ads, if I've essentially leased out a channel of 5 million sats to someone else, they pay based on size, but then I splice out that inbound liquidity that I'm providing to them.
You should just reject that. They cannot splice out unilaterally. They need your signature. Because since splicing spends the funding transaction, which is a 2 of 2, you have to approve that. So if you see that the other guy is splicing out funds that you have paid for, you're just going to reject the splice. But that's something that implementers need to be aware of, and they need to attention and not forget it. Right, I think we're out of time, so thank you.